if you don't mind coming up and getting set up. Next up, we have Vas from Cognee. Besides being the other schemer who originally got the ball rolling for this event, remember Vas was the one who was sitting next to me at the San Francisco VC lunch. Vas is also the CEO of Cognee, and he is an industry expert, if not the industry expert, in long-term agent memory. He's also coming to present all the way from Berlin, so we're very, very grateful that he made the time in his schedule to join us. I think Vas has spent the last 2 years thinking about how to build agents that continuously learn, so that conversations actually compound learning, and you aren't starting from scratch every single time. Vas?
Thanks everyone. Thanks Samuel. I don't think my mother would have done a better job announcing me, so I feel grateful for this one. So I'm Vas. I'm originally from Montenegro, a very small country in Europe. I've been in between SF and Berlin for the last 3 years building agents. Just briefly about myself, my background's in big data, so I started as data analyst, made my way to data engineer, data product manager, mostly managing big data systems. Then I got bored, went back to study cognitive sciences, and I found this interesting area of higher cognitive processes as an area I could explore a bit more. And then LLMs showed up, ChatGPT showed up, and I figured, well, we might need something like memory for agents. And it was 3 years ago, it wasn't particularly obvious back then. But here we are now, it seems it's necessary. Happy to be here, happy to have organized this together with you. And I'm going to tell you today a bit about what is Cognee, what is memory, what are some things we learned as we were building in this space with Cloud Code, Codex, and others. And I'm going to show you a small little demo of how we kind of think about it, and I'm pretty open to questions. So what's Cognee? Cognee is an open source Python framework. We think of it as a memory control plane for agents. What you can do with it, you can ingest data from any type of a data source. So let's say audio, images, text data. We support 30 plus type data sources from your Notion to your relational DBs and Kafkas. And then we take the data in, we parse it and model it. We do knowledge structuring using Pydantic and creating, let's say, representations with graphs and vectors just in pure Python. And anyone can really build these. It's very modular. It's like a data pipeline of sorts. We apply some access control and isolation, so you can really have even physical database level isolation to have your agents access only the things they need. And then we have around 16, 17 types of retrieval you can use or smart reroute to get to the right part of memory you need for your agent. All of this is self-improving as the agents provide feedback to the systems as users use the system. We score and validate certain parts of subgraphs in this context and build better memory that is more optimized to your next query, to your next interaction, and this is something that is pretty much proprietary to us on the self-improvement piece, and that piece is coming from the neuroscience part. Happy to talk about that a bit later, but in a sense today, I think the main topic here is how can I actually use this with my coding agents, and how can I make my coding agents smarter and give them memory.
Can you please put the microphone a little closer? It's very hard to hear.
Sorry about that.
Thank you.
No worries. So I'm happy to be in New York. Someone yells at you and tells you this. In San Francisco they would be like, yeah, it's great. So Anyhow, so we've been used by many companies in the space, from large companies that you see here to a lot of developers from various institutions. We have around 5 million runs a month, around I think 17,000 GitHub stars. This is a bit outdated, and we are fully open source. So if you want to try the product, we are not binding you into anything. You can control your database, your LLMs, whatever you want. So that's the Cognee. This is the problem, right? So when I'm doing some type of development on my end, I'm running into the same problem where I have my front end in React. It's in one GitHub repo. I have some Docker images somewhere. I have Notion, Slack, Jira. I have my Rust engine, infra folder. All of that is different Agentics sessions with Cloud Code and Codex. None of that is really tied in. So what I had to do often enough, I had to really download everything into the same folder so it could actually browse the same things and then keep all of that in line. Then it's kind of trying to find, getting lost, trying to update the wrong thing or push code from different folder to a different folder or copy over things that it shouldn't. So all of that is pretty messy. So since I want to use my own product, right, then I wanted to see how we could actually make this a bit more seamless. We built this solution to a workflow like this. So I have like, let's say, 4 open windows. I'm trying to do 4 different things at the same time, trying to solve different pieces of the puzzle, but often enough they're interrelated. Maybe I'm updating some new feature on the backend and I need to show it in the website. Maybe I'm doing something on the side of the infra and that needs to be also connected to the new variable I'm exposing on the backend. So all that really starts playing together. And to handle that, we basically looked at how we can actually utilize the hooks. So Cloud Code, Codex, all of them have hooks that allow us to trigger an event payload, and we can effectively include some type of an environment within that, which is the current working folder. But not only that, we can return with these hooks JSON response, and we can really trigger external flows that we would need. We found hooks to be quite powerful. Most of you can use them, but for us, basically what we try to get is to get involved in this Cloud Codes and Codex's workflow so we can inject our context. Because we found their context to be relatively poor in terms of what it was providing us. So what we were trying to do is, hey, how about we user prompt submit, we inject context, RAG, memory docs, whatever we need, use the pre-tool use, post-tool use stuff, pre-compact and session end, and for each of these we have a little workflow that's triggering our CLI, and then effectively we are triggering different sets of operations. And we control this with skills. So what is going to happen is you're going to type a user prompt submit hook is going to call Cognee, we're going to store data in MindDB, Kuzu, and we're going to create a semantic graph. We're going to store data in the session store, which in this case is Redis, if we need fast retrieval. We're going to get the top K chunks, traces, subgraphs. We have all these various means we can get the data from, and the cloud is going to answer with that context in. And then when we stop the session, we're going to actually sync all of the data, all of the learnings and findings of that session back to this permanent memory representation that's going to give us this insight in the next session when we start. We're going to know where we left it off. So if I'm reworking my website and I forgot what I was doing 6 days ago, good luck finding that Claude session that you started with. Now you can really just continue and just get the right data from where you were. And you can really localize the right part of the graph. You don't really need to pull all of the context. You don't need to have like 1 gazillion tokens consumed. You're just kind of getting to the right thing with the right pair. And what we then have also is a simple way on the end. After we finished all of this, as we have these sessions, and Cloud Code is very verbose, so is Codex. What we try to do is we really represent the data that matters in this semantic graph. We distill it, and that distillation is happening at the end. So we basically take all of that raw traces, session data, and everything in between, and we put that into the graph. So next time you come, you don't get the information about your 74th failed attempt to deploy in Vercel or something like that. You just get like, hey, okay, this was where I left it off, and this was high-level plan, right? So you want to kind of get to that. So why weren't we doing it with READMEs or Cloud MDs or memory MD files? They are files, they're not databases. So I can just append only, I can't contain traces as sessions, and I have like all of these logs that are being written in some log files, then I need to grep between them. Grep is an expensive operation, although it might not seem so. You're not probably going to want to grep for the eternity, and it's spending a lot of context. So what we wanted to do is have one place to store our both instructions, our sessions, traces, and information. And I'm going to bring the mic up. Thank you again. I love it here. And then effectively what we're trying to get with that is how about we actually build everything into Cognee, because we already supported all of this and we can actually use it more effectively internally. So we initially a year ago, because we wanted users to start easily using our tool, we started using file databases, so Kuzu, LensDB, you've probably heard of them. And it actually proved much more useful for these types of agentic use cases now than it was initially when we just tried to onboard the users without launching Neo4j. Great database, but you need a Docker image, and a lot of people are too lazy to do that these days. So down the line, these types of local file-based DBs are a great replacement in our mind for this README MDs, for all of these types of stores. You do need something to manage them. You can manage them yourself, however you wish. But the point is, how about we actually use the databases because of all the protections they provide? But not only that, if we want to move and migrate to like a server, then we can just spin up the fast API instance and it's going to be available instantly. And I cannot really do that with an MD file. So this is where this actually started becoming quite useful, and it actually enables a lot of patterns of deployment. So if I'm thinking about these databases as files, I can do lambdas, I can send them to sandbox. So we love model, for example, I can put them in a tar and then store them somewhere. I can have just typical Docker images, a container, snapshots, pipelines. We built workflows where different agents inherit different types of artifacts from other agents, the memory artifacts, and just continue executing later on. So basically you're just bootstrapping them warm and continuing along the way, or just processing a lot of data with lambdas per dataset and then storing data in S3. So all of these types of patterns become possible. And then on top of that, you can still spin up a server, host a microservice, handle it in the, let's say, this traditional way too, and it all scales. So that's basically the general gist of the presentation, and I'm gonna show you a bit on the side of how it looks like. So here I am in my, this is, on the left side is Cloud Code, on the right side is Codex, and what I'm having here is effectively, on the bottom part in Cloud Code, I can see that I'm connected to my Cognee's local session with recall and savings. So recall is what am I searching? So am I searching sessions, traces, or graph? Saving, am I saving the prompt? Am I saving like additional context, tool calls, and things like that? On the right side, because of course they don't work the same, basically when I'm sending a user prompt, I can see that basically here I have information about what's being retrieved and what's being enriched in the codex's prompt as it's trying to answer. So both are doing the same thing, one is on top, one is on the bottom. But let's say I say here, I don't know, Amo is a great guy.
I agree with this.
And I hope the gods of demos will be with me today. Let's see. So here is the UI. You can launch it with Cognee CLI-UI. I can see the agents connected datasets calls. And now when I search here and I search for Amo is a great guy. So my whole session got synced. But not only that, I can do the same in Cloud Code. I can say, Agentics rocks. And then I need to add a refresh. That's something I forgot to do. I can search for it here in the session. Yeah, Agentics rock. So I suddenly have information from both Codex and Cloud Code in the same space. But this is nothing particularly fun. Anyone can bytecode this, right? So it's like, okay, I can store traces. But what happens over time is that effectively all of this data is being stored and preserved in this semantic representation I'm going to show you now. This one is a bit big because it has, 28,000 nodes and edges, right? So this is all of the interactions as I was building this demo, and all of the points represent certain types of searches, informations, decompositions on what I was trying to solve and the problems I was trying to answer. And you can basically also search these, and these are also being included in the context of the Cloud Code and Codex as they are looking at. And these are distilled in, let's say, higher representation knowledge than the lower one we were dealing with before. So in the end, what you can also do is you can share the datasets between agents, so you can build different types of datasets and then share them across. But what I also did, just to kind of illustrate it, I loaded a book on San Francisco and on something that definitely Cloud Code wouldn't know about, and that's called Barbary Coast. It's about some area in SF which was very bad in the 1860s, and I can now ask, what is Barbary Coast? And it's going to find it in the graph, and it's going to be able to give me like public knowledge or company knowledge or any type of external knowledge you're bringing in. And that's all of this information that effectively exists outside of the context of these coding agents, and it exists in your Notion pages, and it exists in your databases and elsewhere, where you can also pull that in, and you can do that relatively pretty automatically on the UI, or just do it with the SDK. So yeah, it finds the graph context talks about San Francisco, Barbary Coast, and not the North African one, which is Tunisia and other places where this term came from, if I'm correct, or Algeria, I don't know. Anyhow. So yeah, sorry, I hope I didn't offend anyone. In any case, so what I'm trying to say here is, you can also see your agent sessions, you can see the tokens it spent, you can see the errors that happen, and we are adding the cost, the pricing, and everything else in between. And basically, the whole point of this is illustrated in something like this, a diagram here that shows you that we can take the sessions, we can use hooks, and we should use hooks as much as we can. We can use Cognee to load and index into the databases. You can do that also yourself if you'd like. All of that is really supporting this flow where we can really start moving towards shared context, exchanging context, adding context from other documents and sources. And that's pretty powerful, and that's what it's possible to do today. But of course, we are looking forward to see how this evolves over the next few months, and we have a few more ideas on what to do. So yeah, we are just maybe one more small thing. We are not only doing that. We finished an agentic research system for Bayer, a big pharma company in Germany, where we predict novel scientific hypotheses based on the existing research. So our research team is going quite deep. I'm here on the product side, just also trying to make sure that average person can use the tool and like really have maximum utility from existing agents in the field and harnesses. But we also have a paper coming out on this and a poster that was announced yesterday. So yeah, thank you again for the time. Happy to answer any questions, and I'm around here if you want to chat about memory.
Thanks. This was a great presentation, and I have a question on the memory. When you are using a RAG model to go back in time and to get the context out of it, you have two options. One is a graph, the other one is more of an embedding, the vector embedding. So which one, according to you, becomes more efficient when the volume keeps on growing, and how much is the efficiency when you are actually trying to retrieve the context out of it?
Great question. I would say there is three modes. So there is the graph, the embeddings, and then there is the algorithms on top that are cleaning, pruning, cross-connecting, and handling the actual representation that you need, otherwise it's going to grow too big. You know, like if a human would remember everything he saw, your brain would explode, right? So we always forget and prune, and then that's what we built on top. So initially, usually the embedding works well enough. As soon as you start getting custom domain knowledge or expertise or representations, for example, we are doing a project now with a power plant on Danube in Austria to map like the turbines. Good luck finding that out on the internet, right? So this type of cases require more of a graph structure and some ontology. And then even that is, if it gets too big, you need to prune it. You need to see what parts of graphs were accessed, what not, deprioritize certain areas, delete, organize this in a like. Make sure timestamps are organized in a way you can search historically, see the deltas of change, and have algorithms that can handle that. So I would say all three, where as the data grows, the third one, the algorithmic one, becomes more important, but initially people started with embeddings, and graphs have become useful, and then the next level.
When an agent is learning, how do you make sure it's learning the right things?
That's a billion-dollar question. Good. So when an agent is learning, effectively what we are trying to do is to still have a bit of human-level control on what it is learning and what is the representation. So if we have an ontology that the agent is looking at, and it represents how our knowledge should be connected and how the data should flow through it, we are trying to allow users to change that model and iterate through it and prioritize or deprioritize certain pieces of it. For now, we get pretty good results with default ontologies that we auto-detect from the text, and then let people actually just change what links or areas don't make sense, or what things are not connected well enough on a high level, not on 28,000 nodes. That would be impossible. And then on top of that, what we are now working on is we're trying to treat now the graph as an incomplete world model. And there is a lot of stuff Jan LeCun's doing, and we have a paper that's also going to come out soon on that piece where we're trying to treat this walk through the graph as an optimization problem. And I can announce and talk more about that in a month or two when we have the synthetic data sets and the evals done. Otherwise, it's going to be theoretical at this stage.
Thank you so much.